Namaste students. So this is the second part of projectile up or down and incline lecture series. In this part we are going to derive these expressions that we had found for a projectile which was thrown up an incline. It's very easy. This lecture is going to be very short because we are going to use a very simple trick. But if you have not already watched the lecture about the projectile thrown up an incline, then I will have the I button at the top corner, top right or top left, whatever that is. It will be popping up right now. Go and watch that lecture so you know what are the expressions that are for a projectile when we throw it up an incline. These expressions are here: 1, 2, 3, 4, range, max range condition, then max height, and time of flight. We are going to use these four expressions that we obtained for the projectile up an incline to find out what would be the values, the respective values or corresponding values for the projectile down an incline. Right. So what is happening in this case? Let's quickly go through it. First, this time we're throwing a projectile at an initial velocity u at an angle beta to the incline. This orange line is the incline. Okay. And this incline itself is making an angle alpha with the horizontal axis, right? So this is my x-axis. As you can see, this is in the negative x cap direction because the projectile is this time going in the negative x direction. And yeah, it is sometimes initially it will go up the y-axis, and then eventually it will beyond this point downward it is going to go down the y cap, right? So basically its y coordinate is going to be positive for some time, then it will become 0 and then will continue downwards. So now, starting from the origin O, if the particle hits the the incline at a at a point down the incline at L, so O to L is what we would call O to L is what we would call the range, right? But this time we don't have to go through all that lengthy derivation, right? We have already found the value for the up the incline, and then we're going to use a very simple trick, right? See, as far as the derivation of the up the incline concept is concerned, you don't have to actually use the entire derivation that I did without rotation of frame. You can actually rotate the frame and find an easier way to derive that. It's up to you. But if you already know or remember these formulae from whatever method you use to derive, you can use this technique that I'm going to do to find the corresponding values for the down the incline projectile. Okay. So what are we going to do here? So remember, in the previous case, we were throwing a projectile like this, right? And that was like u, and this was the angle beta that we used to make with the projectile, and this was the angle alpha, right? Clear? And that was the up the incline case. But in this case, so basically what is the direction beta? It's the direction. In our previous case, the direction was the initial velocity, the angle that the initial velocity used to make with the in up the incline direction, right? This is the up the incline direction, up, right? So the initial velocity u making an angle beta along the up the incline direction. But in this case, we are taking the same value down the incline, right? This beta is simply the angle that the initial velocity makes with the down the incline direction, right? So in that means the beta itself is not the same. However, we can define this angle. So basically, what is the angle that u makes with the up the incline direction? Let's call that beta prime or beta dash, right? This angle beta dash. So now if we assume that beta u is making an angle beta dash with the up the incline direction, then the expressions that we obtained would still be the same, right? All we need to do is to just change this alpha plus, just change this to alpha plus beta dash here, max range. This formula would not work here, so don't use this. H would be sine squared beta dash, and this is it's going to be beta dash. So wherever except for the max range conditions, you would not be using that. I'll tell you why. But 1, 3, and 4, all you need to do is to just change beta to beta dash, because in the previous case of the incline, beta was the angle that the projectile used to make with up the incline direction of the incline, right? That was the direction of beta, but this time beta is defined in this way, right? That was u, this is this, and then we are going to simply take this angle up, the angle that u makes with up the incline, the entire angle is beta dash. That's what we are doing. So since now we are taking the angle that we used to take previously as beta is now beta dash, so change all the expressions here to beta dash. That's it. That's the technique. And then we will simply go and derive the things. But what is beta dash? What is beta dash? Yeah, this beta dash angle, this beta dash angle, and this is beta. So beta dash plus beta. So beta dash plus beta. You see, beta dash plus beta together they make 180 degrees, right? So all you need to do is to say that beta dash is equal to 180 degrees minus beta. That's it. Now, this beta here is the angle that is given in the problem, right? That is the angle that the initial velocity makes with a down the incline direction. Yes, and alpha remains the same. Alpha hasn't changed, right? That the incline used to make alpha angle with the horizontal direction, and it's still the same. So instead, now range. First, range will be for down the incline direction 2u squared sine of, instead of beta, yeah, this is beta dash, we should have changed that, but yeah, sine beta dash, but beta dash is simply 180 degrees minus beta, then cosine of, I'm going to take it a little right, yeah, so cosine of alpha plus, instead of beta dash here I will write 180 degrees minus beta, entire thing that you divide by g cos square alpha. That's it. So now you have 2u squared. Sine 180 minus beta is sine beta. No change. Cosine alpha minus, so cosine 180 degrees plus alpha minus beta, right? I can write it like this. Again, divide that with g cos square alpha. Okay, so what about one cos one? Let's suppose this is alpha minus beta, right? If this is alpha minus beta, 180 degrees plus alpha minus beta. Imagine that alpha minus beta is something, any angle A, let's suppose. So cos 180 plus A is minus of cos A, isn't it? So it will be minus of 2u squared sine beta cosine of alpha minus beta, yes, divided by g cos square alpha. But what does this negative sign indicate? This negative sign indicates that the range is now not along, starting from the origin, it is down in the negative inclination direction, right? So we can simply ignore the negative sign, right? We can ignore the negative sign, and eventually we will write that range will be simply, basically we can, here we can simply use a modulus sign, modulus sign, modulus sign. That means if you take the modulus itself, it is going to be 2u squared sine of beta cosine of alpha minus beta, because you already know it's down the incline, so all that matters to you is just the modulus or the absolute value g cos squared alpha. That's it. You found the range down the incline, right? Second, okay, now let's answer what would be the condition for max range, right? Condition for maximum range depending on what value you choose for beta, right? Depending on what value you choose for beta. See, in this expression again, you will have to do dr upon dt beta should be 0. But when you do the differentiation, 2u squared g cos square alpha, this part is again a constant, yes? If this part is a constant, right? If this part is a constant, then the differentiation will only depend on sine beta cos alpha minus beta, right? That means d upon d beta of sine beta cosine of alpha minus beta, right? That will be 0. So in this case, it is going to be cosine of beta into cosine of alpha minus beta, then plus sine beta into derivative of cosine alpha minus beta is minus of sine alpha minus beta, this minus, but then differentiation of alpha minus beta is minus 1, and that is equal to 0. So in the next step, we're going to write cosine of beta into cosine of alpha minus beta, then it's just a positive. Negative is positive, so it's going to be sine beta into sine alpha minus beta, which is 0. So this resembles like cos A cos B plus sin B is cos A minus B. So it's cosine of beta minus alpha plus beta, which is nothing but cosine of 2 beta minus alpha, which is equal to 0, right? See, there is one thing here. We know that cosine of negative of theta is the same as cosine of theta, right? So you might get confused here. We can also write that cosine of alpha minus 2 beta, this can also be 0. Yes or no? So yes, you are correct because cosine of minus theta is cos theta. So both of these conditions could be true, but only one will remain. Let's see how. See, if I say cosine of 2 beta minus alpha is equal to 0, then you will have 2 beta minus alpha will be 90 degrees. Yes, that means beta would be 90 degrees plus alpha by 2, or beta would be 45 degrees plus alpha by 2. So that's the condition for the maximum range down the incline. What about the other one? Alpha cosine of alpha minus 2 beta. If that is the case, now if, okay, let us use uh, that space. Give me just a second. If I take this, so if this is true, if cosine of alpha minus 2 beta is equal to 0, that means alpha minus 2 beta would be 90 degrees, and in this case 2 beta would be alpha minus 90 degrees, and means beta would be alpha by 2, alpha by 2, oh sorry, this is, yeah, that is this will be plus, right? 2 beta would be alpha minus, no, that's correct, I was right. So it's going to be 2 beta is alpha, 2 beta to the right, 9, alpha minus 90. So okay, it's going to be alpha by 2 minus 45 degrees. So that would also be a condition, yes, but this condition will not work, right? Why? See, your alpha, if you look at the incline, what is the maximum value of alpha? See, alpha here, whatever value of beta you choose. If this is u, this angle, this is beta, you can choose whatever value of beta you choose. But alpha is always less than 90 degrees, yes or no? Alpha is always less than 90 degrees, correct? So alpha by 2 will always be less than 45 degrees. That means alpha by 2 minus 45 degrees, right? Alpha by 2, see, alpha is less than 90 degrees always. Alpha by 2 will be less than 45 degrees. Alpha by 2 minus 45 degrees will be less than 0. That's basically this value is negative, right? So if you could have beta which is equal to alpha minus, so beta alpha by 2 minus 45 degrees, then beta would be negative, right? And we are not taking beta as negative, right? We are basically using beta as a positive value when taken as the angle between down the incline and the u. So since we're choosing beta in a particular order, we cannot take this. So we have to stick with this. So this is your condition for maximum range part 2. This is part 2. So now the remaining parts are simple, very simple. So let's see what are the other values. So h, let's copy this. So h is u squared sine squared beta dash by 2g cos alpha, right? So in this case, as we did in the previous case, right? As we did in the previous case, we'll simply write the max height will be u squared sine squared beta dash is 180 degrees minus beta divided by 2g cosine of alpha. That means, see, sine 180 degrees minus beta is still sine beta, right? So it's going to be u squared sine squared beta divided by 2g cos alpha. Clear? That's your part 3. Now what about the time of flight? You must have already guessed it. See, here again, no change, right? But I'll do that anyway. So time of flight is u sine beta dash by g cos alpha. Here, beta dash corresponds to beta in the previous case, right? But in this case, the beta is related to beta dash as 180 degrees minus beta. Beta dash is 180 degrees minus beta, right? In our particular case here, right? So time will be u sine beta dash is 180 degrees minus beta divided by g cos alpha. That means time of flight would be u sine 180 minus beta is still sine beta divided by g cos alpha. I hope that clears the case. So we have third and fourth already done. So 3 and 4. So with that derivation, you now know how to calculate the range, condition for maximum range. Even using that, you can find the maximum range itself. Then max height and time period for a projectile thrown down the incline. And in the previous lecture, we covered about all these things when the projectile is thrown up the incline. With that, I think this topic is covered. So let's see you with a new topic in the next. Till then, keep learning and stay happy. Bye bye.